Let's discuss critical numbers. So what is a critical number? We say that C is a critical number, okay, of the function f of x if f prime of C equals 0 or if f prime of C does not exist. Okay, so these are the two possibilities. Either the derivative is 0 or is that it does not exist. Let's practice computing the critical numbers. So let's say we have f of x, which is x to the power 3 plus x squared minus x. Okay, so we can compute the derivative. So this function is a polynomial. Okay, so right away we know that it's going to be differentiable everywhere. So this is 3x squared plus 2x minus 1. Okay, and if we want to compute the critical numbers to find them, we need to make f prime equals 0 and solve for x. Okay, in this case, we have 3x minus 1 times x plus 1 equals 0. That means that the critical numbers are x equal 1/3 and x equals -1. Okay, and these are the critical numbers. And that's it, because the function is differentiable everywhere. But now, how about the function f of x, that is x to the 4/3 minus x to the 1/3? Okay, in this case, we can compute the derivative. 4/3 x to the 1/3 minus 1/3 x to the minus 2/3. Okay, so we can make, to find the critical points, we can make f prime equals 0, right? That means 4/3 x to the 1/3 minus 1/3 x to the -2/3 equal 0. And now we just simplify. Okay, this means 4x to the 1/3 equal x to the -2/3. This is like 1 over x to the 2/3, right? So we can push everything to the left, and then it would be 4x to the 1/3 plus 2/3 equal 1. Okay, but this is x, because the 1/3 plus 2/3 make 1. So we have 4x equal 1. That means x equals 1/4. All right. Is that it? Well, remember, we need to also check. We checked f prime of x equals 0, but also check f prime of x does not exist. Okay, and there is a delicate point here, right? X equals 0, because you see, sorry, when we take the derivative of x to the 1/3, we get a negative exponent. Okay, so if you check the definition, you will see that the derivative that does not exist at x equals 0. Okay, so x equals 0 is also a critical point. Let's plot this function to see how to look at what we are computing. Okay, so let's say we have x to the power 4/3, and then I'm subtracting x to the power 1/3. Ooh, that didn't come out right. there, minus x to the power 1/3. There we go. This is how the function is going to look. And if you notice, when we look at this graph, there are clearly two critical points. Okay, one critical point is where we see there is a minimum. Okay, but that would correspond to the point when we look at it, it looks like it's roughly 1/4. Okay, 0.25. And then at 0, we see that the slope is vertical. Okay, that's consistent with having the x to the negative 2/3, because at 0 that would become 1/0 would become infinity, right? So that means a vertical tangent.